The role of temperature in chameleon metabolism is a critical aspect of their biology, influencing various physiological and behavioral processes essential for their survival. Chameleons, like all reptiles, are ectothermic organisms, meaning their body temperature and metabolic rate are significantly influenced by the ambient temperature of their environment. This ectothermic nature dictates a unique set of adaptations and behaviors aimed at regulating body temperature, which in turn affects their metabolism, activity levels, digestion, and even reproductive success. Temperature regulation is paramount for chameleons as it directly impacts their metabolic rate. Metabolic rate in ectotherms, unlike in endothermic animals such as mammals and birds, does not remain constant but varies with external temperatures. In chameleons, a higher ambient temperature within their preferred optimal temperature range, POTR, accelerates metabolic processes, leading to increased activity, faster digestion, and generally more efficient physiological functioning. Conversely, lower temperatures slow down these processes, reducing the chameleon's metabolic rate, which can lead to decreased activity levels and slower digestion. The preferred optimal temperature range for chameleons varies among species, largely depending on their native habitats. Species originating from warmer, tropical regions may have a higher POTR compared to those from cooler, high-altitude areas. Within this range, chameleons can effectively regulate their body temperature through behavioral adaptations such as basking in the sun to increase body temperature or seeking shade to cool down. This behavioral thermoregulation allows chameleons to maintain their body temperature within a range that optimizes metabolic efficiency. Basking is a common behavior observed in chameleons and is crucial for thermoregulation. By exposing themselves to direct sunlight, chameleons can absorb heat, which not only elevates their body temperature but also aids in the digestion of food. The warmth increases enzyme activity in the digestive tract, facilitating the breakdown and absorption of nutrients. This is particularly important after feeding, as the increased metabolic rate allows for quicker digestion of food, which is essential for their energy acquisition and overall health. Conversely, in cooler temperatures, the metabolic rate of chameleons decreases. This reduction in metabolic activity can lead to lethargy and prolonged digestion times. In extreme cases, if the body temperature drops too low, chameleons may enter a state of torpor to conserve energy, significantly reducing their metabolic processes. This state can be risky as it makes them more vulnerable to predators and can impair their immune function. Temperature fluctuations also influence the chameleon's hydration needs. Higher metabolic rates at warmer temperatures increase water loss through respiration and evaporation, necessitating more frequent hydration to maintain physiological balance. Chameleons typically hydrate by licking water droplets from leaves, and their need to hydrate becomes more pronounced as their metabolic rate increases with temperature. Reproductive processes in chameleons are also closely tied to temperature. Optimal temperatures can enhance fertility and reproductive success, with temperature influencing the development of eggs in females and sperm production in males. Incubation temperatures of eggs are particularly crucial, as they can determine the sex of the offspring in some reptile species, a phenomenon known as temperature-dependent sex determination, TSD. The immune function in chameleons, as in many reptiles, is temperature sensitive. At optimal temperatures, a chameleon's immune system operates more efficiently, enhancing its ability to fight off infections and diseases. However, at suboptimal temperatures, the immune response can be compromised, making chameleons more susceptible to illnesses. Understanding the role of temperature in chameleon metabolism is essential for their care in captivity. Providing a thermal gradient within the enclosure allows chameleons to thermoregulate by moving between warmer basking areas and cooler shaded areas. This gradient is crucial for mimicking their natural environment and ensuring their physiological needs are met. Caretakers must closely monitor and maintain appropriate temperature ranges to support the health and well-being of captive chameleons, ensuring they can engage in natural behaviors such as basking, feeding, and resting within an optimal thermal environment. In summary, temperature plays a pivotal role in the metabolism of chameleons, influencing their daily activities, digestion, hydration, reproductive success, and immune function. The ability of chameleons to regulate their body temperature through behavioral means is a fascinating aspect of their biology, highlighting the intricate relationship between these creatures and their environment. As we continue to study and understand these relationships, we can better appreciate the complexity of chameleons and the delicate balance required to maintain their health and vitality, both in the wild and in captivity.